Hello everyone, this is my first podcast from my YouTube channel Learning from Data. I will create a series of podcast videos for my YouTube channel. So far, I have discussed various statistical concepts in my Medium blog as well as in my YouTube channel. As a starting point, I will talk about descriptive statistics in this first podcast, which I believe will be very easy to understand for everyone. I will first talk about some measures of central tendency. All of us know that when we have a dataset, it is just a sample of the whole population. For example, if you want to get the average height of all the people of the whole world, you cannot measure all the heights of all the people. It doesn't make sense. So what we do, we just take a sample and measure the height of those sample. So we are trying to predict the population statistics from the sample. So we are basically trying to conclude that our sample should be a representative of the whole population. So it's basically an inferential statistics issue. So when we have a sample from the whole population, we need to make sure that those samples are randomly collected. Otherwise, if the sample have if the samples are biased, then our conclusion will also be biased or misleading. A measure of central tendency gives us a single figure or a single number that will be representative of the whole population. There are many measures for central tendency, such as mean, median, and mode. We'll talk about all of these subsequently. First of all, let's talk about mean or average. Mean is the most used measure for central tendency. It has some pros as well as some cons. Actually, all of those measures for central tendency have pros as well as cons. Calculating mean is very simple. We just add all the numbers in our hand and divide that number by the total number of samples. For example, if we want to obtain the average height of all the people in this world, we just take a sample. For example, we take 1,000 samples and add all the heights of those 1,000 people and divide that number by 1,000. In this way, we get a single number, which is the average of that sample. In this case, if the sample is random, it will truly represent the population. So we can say that if our sample is random and it is not biased at all, then the sample mean will be very close to the population mean, or in this case we can say that it will be very close to the actual height of all the people in this world. Another measure for central tendency is median. Median is basically the midpoint of the sample. So the median is that value above which there are 50% of the data and below which there are 50% of the data. So median is exactly the midpoint of the sample. To obtain median, we first need to sort the sample from high to low or low to high and get the midpoint. If the number of samples is an odd number, then we just get the midpoint or the number in the middle. If the number of sample is an even number, then we need to take the two values in the middle and add those two values and divide by 2. In this way we'll get the median value of the sample. Earlier I mentioned that there are some pros and cons for all of the measures of center tendency that I'm going to talk about. For example, mean has some pros as well as some cons. The data that we collect in the real world are not normal. Sometimes it is very close to normal, and most of the time there are some outliers, there are some extreme data points that may be the result of some human error, or there may be some real issues in the data. We really don't know. So the real world data is sometimes very much skewed, and in those cases we need to make sure that we are taking the right measure for center tendency. For example, if we have a sample that has a very good distribution, let's say it's perfectly normal, then your mean as well as median is the exact same point. If the data is skewed, then the median and mean differ from each other. The higher the skewness, the higher the distance between the mean and the median. So the question is, when should we use mean and when should we use median as our measure for center tendency? If our sample is normal or nearly normal, then it doesn't matter if we use mean or if we use median. On the contrary, if the data is skewed or if the data has some extreme outliers, then we need to depend on median instead of mean. Because if the dataset contains some outliers or some extreme values, then those values will have some significant impact on the position of the mean. What I'm trying to say is those outliers will impact the mean values, but median values will be not much affected because of those extreme values, because median is position dependent. You sort those values from ascending to descending or descending to ascending and get the midpoint. It doesn't matter if that the last values or the first values are extreme high or extreme low. It doesn't matter if we use median, but it matters in case of mean because we are taking those extreme values to calculate mean. For example, if we have the dataset of a sample of 1,000 people's height, and in some cases maybe there are some human error in keying the heights, or there may be some typo, and if those dataset are taken into consideration, then we might end up some extreme outliers or maybe some kind of skewed distribution. So we need to really look at our dataset and understand our dataset first. If you think that your dataset is okay and it is there is no human error, or there is no such kind of extreme outliers, then we can use mean and to make sure that the dataset is nearly normal or normal. Or in the other case, if the dataset contains some extreme outliers which are valid, then we need to probably use median to calculate the measure for center tendency. There is another measure for center tendency, which is mode. Mode is the least used measure to determine center tendency. I don't know why, but it is the least used measure to obtain the central tendency of a dataset. Usually the mode is the most frequent value in the dataset. For example, if we calculate the height of all the people of our sample, then we need to find out which value is the most frequent, and that value will be the mode. If there are two values which are occurring most often, then we will have two modes in our dataset. Well, we have covered very basic understanding of mean, median, and mode, and also we have discussed about the pros and cons of using mean and median. Now we will talk about another important aspect of descriptive statistics, which is standard deviation, and also some textbooks use the square of a standard deviation, which is called variance. In layman's term, standard deviation is just the measure of dispersion. Let's clarify the idea of standard deviation using two datasets. We have, let's say, first dataset contains two values, 5 and 5, and our second dataset contains also two values, which are 0 and 10. The average of the first dataset is 5 plus 5 divided by 2, which is 5, and the average of the second dataset is 0 plus 10 by 2, which is also 5. But although their mean are exactly same, they are vastly different dataset. So how can we differentiate between these two datasets? The answer is standard deviation. As I mentioned earlier, standard deviation is a measure of dispersion. It measures how dispersed the values are from each other. For example, in our first dataset, the values are 5 and 5. The difference between these two values are 0, because these two values are exactly same. Therefore, there is no standard deviation at all. Of course, there is an equation to measure this standard deviation. You can look for it in any standard textbook, but that's not I'm trying to discuss here. But my point is to differentiate between one dataset from the other. In our second dataset, the values are 0 and 10. In this case, the values are dispersed from each other by 10 units. Therefore, the standard deviation will be higher than the first dataset. Sometimes deviation is also measured by variance, which is the square of standard deviation. Well, I hope you have liked this first podcast about descriptive statistics, which includes measures for central tendency as well as measure for dispersion. In my next podcast videos, I'll talk about some other statistical concepts which I have already talked about in my Medium blogs, but I will try to focus on the basic understanding of those statistical concepts. My focus will not be those hardcore equations or formulas from statistical textbooks, but very much on the basic and fundamental concept of those ideas. Till then, happy learning from data.